This is a training video about the message communication from a client PC to a server.
The OSI TCP IP model has 5 layers: the application layer, the transport layer, the internet layer, the data link layer, and the physical layer. The client PC starts off in the application layer of the OSI TCP IP hybrid model. We will now discuss how the messages move down the layers of the model and eventually pass to the server.
The application layer is the highest layer in the OSI TCP IP model. The layer implements user-required functionalities and also handles data formatting, coding, compression, and encryption. There are numerous protocols that reside in this layer. They include the application protocols such as HTTP, FTP, and SMTP for providing end-user services, as well as administrative protocols such as SNMP, DHCP, and DNS. This layer will later tell the server how to handle the data. For this, we will be using an HTTP message. There are 2 types of HTTP messages, requests and responses. In this demonstration, our client PC is sending out an HTTP request message. An HTTP request contains an HTTP method, in this case a GET method, the HTTP version, in this case an HTTP 1.1, and headers such as user agents and accept language. After the HTTP message is added, the package is then pushed down to the transport layer for further encapsulation. The transport layer's primary job is to facilitate end-to-end communication over an internetwork. It allows for logical communications to be made between devices. This layer deals with quality of service, reliability, flow control, error correction, and it also controls dialogues between processes. The key TCP/IP protocols at this layer are Transmission Control Protocol, TCP, and User Datagram Protocol, UDP. The application layer data is broken down into TCP segments. The segments are encapsulated by the TCP header. The TCP header includes the source and destination port numbers and segmentation order information. After segmentation, the TCP segments are then pushed down to the internet layer. The internet layer deals with delivery of information, logical addressing, and routing. This layer takes the TCP segment and encapsulates them with IP protocols and creates an IP packet. An IP header added, which includes the source and destination IP address and the IP version used. The IP address will later be used for routing. The packets are then passed down to the data link layer. The data link layer services the network layer by transferring the datagram from one node to the adjacent node over a link. The data link layer activates, maintains, and deactivates a reliable link between local devices. It is in close relation with the physical layer. The data link layer functions are logical link control, or LLC, media access control, or MAC, data framing, and error detection and handling. LLC and MAC are considered to be sublayers to the data link layer. When labeling the data link layer, we use the Ethernet frame. This is the data framing function, which is the final encapsulation of the higher layer messages into frames. The frames are then sent over the network at the physical layer. The Ethernet frame has a header, data field, and trailer. The header has multiple fields. One is the MAC header, and the other is the LLC header. The MAC header contains the MAC address, which is a 48-bit hexadecimal that is used to get the frame from one interface to another physically connected interface. The trailer contains a frame check sequence for error detection. The physical layer is the lowest layer of the OSI TCP IP hybrid model and the physical interface between devices. Physical layer technologies are the ones that deal with the actual ones and zeros that are sent over the network. As you can see, we are not adding another box or label for this layer. This is because this layer physically moves the data across the network interface and does not consist of any TCP and IP protocols. It deals with the actual hardware and devices. The function of this layer are the definition of hardware specifications, encoding and signaling of data bits, data transmission and reception, and topology and physical network designs. The technology used in the physical layer generally implement multiple layers of the model that we have now described. For example, the Ethernet network interface card or wire performs functions from both the data link and physical layer. For this demonstration, this Ethernet cable is the media that our physical layer is using to carry the data from one network to the Ethernet switch. The Ethernet switch recognizes the physical layer and the data link layer. It receives the data transmitted through the cable. An Ethernet switch is considered to be a data link layer device because it's a smarter physical layer technology. The switch recognizes the data link layer Ethernet frame that was transmitted over the physical layer cable. It can also check the frame header, which is the MAC address, and decide whether to forward it on to another place based on that information. This layer is essentially just checking out the data link Ethernet frame and forwarding it on to the next destination, which is the router. The job of the router is to connect networks, and it begins at the physical layer. The router takes the packet and sends it up to the data link layer, where it is then processed, checked for errors, and has the data link headers removed. The router then sends the packet up to the internet layer, where the router determines the address of its destination. The router will then check the routing table to decide the destination.
Aha! The destination is a server.
After this determination, the router repackages the packet and sends it back down the physical layer, where it is then sent to its next destination, the server. The server's purpose is to serve the client computer's request, hence the client-server architecture model. While multiple clients can request a server at a time, this demonstration we just have one. The server has the same layers as the client computer. First, the server removes the data link layer header and converts it back to the IP packet. Then it removes the internet layer and the IP packet headers and converts the packet back into TCP segments. Then the segments are reassembled into the original data of the transport layer. As the server unpacks the client request data, the transport layer that contains the TCP segments give the server the port number. This port number directs the server to the correct type of application protocol to use. In this case, we are using a port number of 80 because in this demonstration we are using an HTTP application. The server then retrieves the data that corresponds to the client's HTTP request, in this case, and sends the response back to the client. This concludes the OSI TCP IP hybrid model message communication training video.
Thanks for watching!